In today's session, we will discuss about programmable devices. The primary function of the microprocessor is to accept the data from the input devices like a keyboard and switches. So, to accept the data or to get the data, it will read the data from the keyboard or input devices. And also the same thing, the data microprocessor want to send the data to the output devices like a monitor, display devices or LEDs. So, it will send the data to the output devices. To send the data means it write the data into the output devices. So, the primary function of the microprocessor is accepting data, sending the data, that is read and write operations are performed. So, this kind of operations are performed with the input devices and output devices. So, this is called as the I/O devices. So, the I/O devices mainly for supporting devices of the microprocessor. The microprocessor performing the data transfer with the peripheral devices. Sometimes the microprocessor is more speed than the peripheral devices. So, that time the microprocessor introduce the wait states to synchronize the matches or to synchronize the speed of the data transfer. Sometimes the the peripheral devices is more speed than the microprocessor. So, that time they are introducing the DMA operations. This is one kind of I/O operation, that is DMA is direct memory access. So, when the peripheral device is more speed, then it perform the DMA operations. With the help of that, the data is transferred between the microprocessor and the peripheral devices. So, either the speed of the data transfer is matched by introducing the wait states or by using the another I/O devices. So, generally the I/O devices are either interrupt I/O, DMA I/O, this kind of I/Os are performed. The design of logic circuits is called as the interfacing I/O devices. This interfacing I/O devices are activated by using some software instructions. So, this is called as a interfacing devices. In today's session, we are discussing the programmable devices. Programmable devices means with a single device, we are writing some instructions for the specific applications. That is, by writing some instructions, we can use it for the different applications. So, this is a multiple functions are performed in the single devices. That is why it is called as a programmable device. By a single device, by using the instructions or by using the program, we can design for our specific applications. So, we will discuss programmable device along with one of the programmable device, which is a 8155, which is a parallel interface. So, programmable interface is designed for the various input and output functions. So, this functions can be different for the different applications. So, the specific applications can be selected by writing the some instructions. So, by writing some instructions which are performed in the control register. With the help of control register only, we are activating the devices as either input or output. The functions can be changed at any time during the program executions by writing some new instructions. So, by writing some new instructions, we are designing the devices for multiple applications. That is why it called as a flexible device, and also instead of designing a single device for single applications, now single device is used for the multiple applications. So, it also called as a economical. The functions can be determined by the software instructions. So, it can be used for the different applications for by writing the different coding. So, it also called as a multiple I/O device, or simply we can define many devices in a single IC. So, in the programmable device, what are the devices are included means some input buffer or input registers, output registers, then device selects. So, these are the devices which are supporting for the peripheral interfacing, input and output registers, tri-state buffers, capability of bidirectional data flow, then some handshake and interrupt signals are used. Handshake signal is used to avoid the data loss. Suppose the different mismatch speed is performed between the processor and peripheral device, that time they are using the handshake signal for the confirmed data transfer. Without losing the data is transfer between the peripheral and microprocessor, and also to avoid the ideal time, the interrupt signals are used. Suppose the processor interfaced with the peripheral devices, example in the input device. In the input device is a serial device, so it will collect the data bit by bit. but the processor is a parallel device. So, the bit by bit data is collected in the buffer, then the buffer is after filling it will send the signal to the processor convert the serial data into parallel data, then it will take. So, to avoid the repeated checking and also for ideal waiting of till the buffer is full, they are using the interrupt signal. So, the interrupt signal is used when the buffer is full, then the processor will take the data for the conversion. So, during that time the processor will do the remaining works. Then control logic is used for the proper read and write operations. Then chip select logic is one of the important because we are performing all connections and also we are writing the coding properly. Without enabling the chip we cannot perform the any functions. So, we have to activate the IC first, then we have to apply the input signals, then we have to write the coding also. The next one is interrupt control logic. So, these are the important elements which are used for the peripheral devices. So, one of the devices bidirectional buffer. So, bidirectional buffer is a temporary storage device which is used for receiving the data. So, the data is available on the buffer. Here we are specifying bidirectional data. Bidirectional buffer means the data can be read either from left direction or from the right direction, or you are considering two end as A and B, the data flow from A to B or B to A. So, any directions you can read the data, that is why it called as a bidirectional buffer. So, this simple diagram represents how the data is transferred from A to B and B to A. So, to control these directions they are using the DIR signal. Along with that we have to activate the device by using the gate signal. The gate signal is active low signals, here they are using the NAND gate. So, when we are applying 0 signal on this gate, with the help of DIR and G, two control signals will define the flow of the direction. So, the gate signal is always 0, when we are applying the 0 then the input signal is 1, then the DIR is a main signal which is suppose we are applying the signal as 1, here is 1, then here it is inverted. So, it become a 0, here the gate signal is 0, so here 1. So, both signals are 1, so here only the data signal is enabled. So, when we are applying the direction is 1 or which is a high signal, then the data flow from direction A to B. Suppose you are applying the signal low for the DIR signal, the gate signal is always 0 because it is active low signal. When you are applying 0 by the inverter it become 1 on both NAND gate. Now, you are applying the signal as 0. So, when you are applying 0 the output is 0, then this value is inverted. So, 1. So, the second gate is now enabled. So, now the direction of data flow from B to A. So, from that what they are saying, bidirectional buffer is controlled by using the DIR signal. When the DIR signal is high, the data flow from A to B. When the signal is low, the data flow from B to A. So, with the help of this kind of additional signals, we can control the flow of data. The another one is control word. The control word is very important in the programmable device, which is used to define the ports or the functions for the specific applications, whether you can enable it as a input or output. So, the corresponding elements will be set in the control word. This is a 8-bit or 16-bit word. By using the specific on and off positions or set and reset positions, we are activating the specific applications. So, the content of the control register is called as a control word. So, control word we have to initialize in the program to activate the or to properly make the interfacing. Programmable peripheral device, most commonly they are using the more supporting devices. So, in today's session we will discuss about 8155. 8155 is a programmable peripheral interface. This is one of the parallel communications. So, parallel communication means by the name you can identify it have number of lines. So, here also it have a 3 ports with the 8 bits, 2 ports are 8 bits and a single port is a 6 bits. So, totally 22 pins are available for the parallel communications. So, this 8155 is commonly used for with the 8055 for peripheral parallel interfacing. This also used for the multipurpose programmable device because it has a 256 RAM with 3 ports and a timer. That is why it called as a multipurpose programmable device. Additionally, it have a 4 control signals which are ALE, IO memory bar, read and write signals. These control signals are directly connected with the microprocessor. So, no need of the external circuits. By using that also the cost is reduced and also the speed of the processing is increased without external circuits. This diagram shows the pin diagram of 8155. This is a 40 pin IC, which is a dual inline package. That is why it called as a DIP. So, 40 pins, among the 40 pins 3 ports which is named as port A, port B and port C. In port A we have 8 signals which are denoted as 0 to 7, and port B we have 8 signals which are denoted as 0 to 7. This is 7. Then in port C only 6 signals are available. So, 0 to 6, 0 to 5, PC0, PC1, PC2, PC5, PC3 and 4. So, totally 6 signals plus 8 and 8, 22 pins are available for the ports. So, these 3 ports can be used as either input or output. So, at a time we can use it as a 22 input lines and also 22 output lines. Then for every IC we need a 2 power supply signals, which is VCC and VSS, that is a ground and positive signal. Then it has a 6 control signals, which are read bar signal, write bar, ALE, IO memory bar, reset signal. So, the ALE is a address latch enable, which is used to demultiplex the address and data lines. Then WR bar is the write operation, RD bar, chip select, then IO memory bar. Reset is used for internally reset the signals. So, these 6 are the control signals which are directly connected to the processor, because the same name of the signal is available on the microprocessor. Then it has 8 address and data lines, AD0 to AD7, which are multiplexed. Why we are multiplexing the address and data lines means to reduce the number of pins. For the compact design, the address and data lines are multiplexed. So, to demultiplex automatically they are using a single signal, which is ALE. It when the signal is active high, then it acts as a address line, otherwise it acts as a data line. Then for timer purpose, it have 2 signals, which is timer in and timer out. The timer in and out is simply passing the pulses. So, based on the pulse only it counting the numbers, which is acting as a counter or timer purpose. This is the pin diagram of 8155, which will shows the 40 pins. Among the 40 pins, it has 3 ports with 22 pins, 2 power supply signals, 6 control signals and 2 timer signals. One is timer in and timer out. So, in the 8155 it has 3 ports. Along with the 3 ports, it has 2 timers with a memory. So, how this pin diagram or the function of the 8155 is divided means, it is divided as 2 sections. One is memory section, another one is a timer section. In the memory section, that is instead of timer, it is a programmed IO. In the programmed IO, it have ports and the timer. The memory section, it has only the RAM, which is a random access memory. We can perform the read and write operations. So, it has 2 sections. First one is 256 byte read write memory or RAM. The another one is programmable IO. In the programmable IO, it has 2 8-bit ports, which are named as port A and port B. Another one is a 6-bit port, which is named as port C, and it has a 16-bit timer. The 16-bit timer also named as LSB and MSB, that is lower byte, higher byte. In the higher byte, which they named as a MSB, most significant byte, LSB is least significant byte. So, we will discuss how to initialize the timer along with the ports. This diagram shows the functional diagram of 8155. In the 8155, this is the memory section. The size is 256 cross 8. The 8 represents we are reading the data in byte vices. This is the static RAM. Then it has a timer with the 3 ports, port A, port B and port C, which are connected with the corresponding signals. The port A is a 8-bit signal, which are denoted as PA0 to PA7. Port B is a 8 signal, which are denoted as a port B 0 to 7, and the port C is a 6 signals, which are denoted from PC0 to PC5. So, totally 22 signals available for the parallel communications. So, these 3 port signals are either you can use it as a input signals or you can use it as a output signals. That is why here we are representing it as a bidirectionals, because it can be used as either input or output at a time. Then it has 2 power supply signals, which is VCC and VSS. VCC is a positive signal and Vs is a ground signals, which is to activate the DC voltage is used to enable the device. For the timer signal, it has two signals, which is the timer clock and timer out. The timer in is also named as a timer clock, which is used to give the continuous clock pulses to the timer. So, based on the number of clock pulses, it will count the signals. Timer out means it will generate the pulses for the external devices. Then this is the address and data lines. The data line is used for the read and write operations. That is why here we are giving as a bidirectional. Actually, the address is a unidirectional line. Address is used to specify the location. The data line is used to transfer the data between the peripheral and processor based on the interfacings. Then remaining signals are called as a control signals. This is the IO/memory bar. So, when the signal is high means it represents the data is transferred between the peripheral and the processor. When the signal is low means it is a memory related operation is performed. So, the data transfer between the processor and the memory. This is a chip enable signal which is used to activate the 8155. When the signal is low means this IC is enabled. Without applying low signal on this pin, we are applying another signals properly, we would not get the output, because we have to activate the chip first, then we have to apply the corresponding signals. The ALE signal is used to demultiplex the address and data bus. This is the address latch enable, which is used to latch the address lines. These two are the very important signal which is used to perform send and receiving the data. This is a read bar signal. The bar represents this is the active low signal. When the signal is low means it represents it perform the read operation. The another one is write bar, which is the active low signal which is used to perform the write operation. Write operation means the processor write the data into the peripheral devices. Reset, this is one of the signal which is used to reset the device. Reset the device means it will temporarily clear the signal. So, these 5 signals IO memory bar, ALE, read bar, write bar and reset, these are the control signals along with the chip select or chip enable signals. This is the address and data lines. This is a functional diagram of 8155, the two signals for timer clock and timer out, that is timer in and out to enable the timer. Timer is used as a counter, it will count the pulses. Then 2 power supply signals along with the 3 ports. The ports are bidirectional which have a 22 pins. So, this is a functional diagram of 8155. So, in the control logic we have control signals which are already named as IO memory bar, ALE signal, then a read bar, write bar. The same signals with the same name is available in the microprocessor 8085. When we are making the interfacing of 8155 with the 8055, the ALE signal is directly connected with the ALE of 8085. The read bar RD bar signal is directly connected with the RD bar of 8085. The same thing for WR bar. WR bar is a write operation which is directly connected to the 8085 WR bar signals. Along with that IO/memory bar, that signal also same signal is available. So, you can directly connect it. So, no need of the internal blocks or additional or external circuits to interface the control signals along with the 8085. That is why it will eliminate the external hardware devices and also we can easily perform the interfacing without any additional circuits. So, automatically the speed is increased without using the additional circuits, because of the it avoid the propagation delay also. So, when we are interfacing peripheral with the peripheral devices, first we have to connect the address lines where we want to write, because we have a number of ports. So, which port you want to select, you give the address, then which data you want to send on the display device. So, the data also available on the data bus. To send the data, we have to enable the WR bar signal, that is the write operation we are going to perform. So, these 3 signals we have to enable, then by writing some coding we are activating the programs. First physically we have to make the connections, then we have to write some codings or some instructions. This is called a interfacing. So, after making proper interfacing with the proper programming, we can send the data from the processor to the peripheral device. So, there are 6 control signals. The first control signal is chip enable. chip enable or chip select, which is used to activate the IC. By applying this is the active low signal, by applying the 0 signal, the IC 8155 is now active. The another one is IO memory bar signal. IO memory bar signal means it is used to specify whether peripheral device is operating with the memory or with the peripheral device, that is the processor is performing with either memory or peripheral devices. When the signal is high means it represents this is a IO operations, that is performing with the peripheral devices. When the signal is low, this is a memory related operation. The another one is ALE, which is address latch enable. When the signal is high, then it pass only the address lines. When the signal is low means AD0 to AD7 is act as a data lines. The another one is a RD bar signal, which is a read operation, which is active low signal. When the signal is enable means it represents the processor read the data from the input devices. The another one is write bar signal, which is used for write the data into the output device. This is the active low signal. When the signal is enable means now the peripheral send the data to the output device or it write the data into the output device like a LED or any monitor devices. Another one is a reset signal, which is used to reset the internal devices of 8155 along with the supporting ICs. So, in the IO ports it has the control register, then timer and 3 ports. The control register is one of the main thing which is used to activate the 8155, which port is used as a input port, which port is used as a output port. So, for that it has a 3 ports, already we have discussed port A, port B and port C, and it has a timers with the 2 8-bit registers. The 2 8-bit registers are named as a LSB or MSB, least significant byte and most significant byte. So, whenever you want to initialize the data, suppose you have only 8-bit data, you can use any one of the register, either MSB register or LSB register. Suppose you have a 16-bit data, the lower byte should be initialized in the LSB, higher byte should be initialized in the MSB. This simple diagram explains how to activate the ports or how to enable the ports and the timer. Actually, this is the interfacing, so we have to concentrate the how the address lines are connected. Based on that only we have to calculate the port address. When you are synchronizing the port address with the interfacing, then only the program will be executed. So, for that you have to see the daughter board or the additional card, how the interfacing is performed, then only you have to start to write the program. So, for that to calculate the address lines or port address, how we are calculating. The port address is calculated based on the address lines. So, it has 8 address lines which are multiplexed with the data lines. So, to demultiplex automatically we have to use the latch. So, this latch is activated with the ALE signal. Once the latch is enabled means it will generate the 8 output lines A0 to A7. So, among the 8 output lines we are used only the required signals, remaining signals are not used. So, here we are using because we need only 6 signals. So, for that here they are using the 3x8 decoder. So, 3x8 decoder means 3 input lines along with the 8 output lines. 3 inputs which are denoted as A0, A1 and A2. These 3 signals, when these 3 signals are 0 means the output 0 will be selected. 0 0 1 means port 1 will be selected. Suppose you want to select the port B. Port B means the output 2 you have to activate. To activate the output 2 means here you have to give the signal as 0 1 0. This is a binary equivalent for 2, 0 1 0. When you are applying 0 1 0, the 2 will be selected. This way we are giving the address lines to activate the particular signal. Suppose you want to enable the timer LSP means 1 0 0, that is the binary equivalent of 4. That signal is given, then automatically the timer LSP will be selected. To time for timer MSB you have to give the signal 1 0 1, this is a 5 equivalent. So, these signals based on the address lines, the 6 signals will be selected, either control register, port A, port B, port C and timers. So, after giving the address lines based on the line, the corresponding address will be given to the port A, port B, port C and timers. So, this is a simply port selection, how we are selecting the port address based on the address lines. So, this shows the address lines A0 to A7. So, among the A0 to A7 only 3 address lines used for the decoder. remaining address lines are not used, that is why it given as a block color. So, based on our previous discussion, not unused address lines are considered as high level. Then when all the signals are 0 means we want to select the control register. So, to interface processor with the peripheral, we are using the 8155. So, when via the 8155, first we have to calculate the port address, how we are making the interfacing. Then we have to use the control word, based on our requirement we have to initialize the control word in the control register. These two are very important in the interfacing. So, this diagram shows the interfacing, the same thing how we are using the decoder. In the previous case simply we are discussing the decoder, here we are discussing the enable signal. So, the unused address lines, 2 signals are connected with the 2 enable signal and one more address line is connected with this E3 or plus 5 volts. So, this decoder 3x8 decoder have a 3 address line with the 3 enable signal. In the 3 enable, E1 and E2 are active low signals. So, we are connected with the inverter, then E3 is a active high signal. So, based on this, the unused address lines are used as the connector, used as the enable line. So, based on that we are calculating, suppose the unused A7 to A3, this is active high enable signal, these two are active low enable signal. So, we are using the 0 signal, A3 and A4 is not used. So, we are giving as active low signal. A0 to A2 is used, when these 3 signals are 0, then it is used to select the control register. So, based on that 20, when 001 is applied, it will used to select the port 1. So, the 21 is the port address for the port A, this is the port address for port B, this is the port address for port C 23, 24 is the port address for timer LSP and 25 is the port address for the timer MSB. By activating the corresponding signal, the corresponding address we are getting. So, we have to calculate the port address, then we have to write the control register, then only we can interface the program. So, in the today's session we have discussed what is programmable device or what is IO device, how we are converting it as a programmable IO devices. So, in the programmable IO device most commonly we are using the 8155, which is a programmable peripheral interface device. So, we have discussed what is the 8155 features along with its internal architectures. Question section, what is programmable device? Give some example. Draw and explain the pin diagram of 8155. Briefly explain the internal architecture of 8155 with neat diagram. Thank you.